previous lecture we have seen dissociation of ions and electrical conductivity. Now we are going to see electrolysis. Okay, so as we know, dissociation of ions takes place in aqueous solution, and if we carry out this process of dissociation in presence of current, we can call it as electrolysis. Okay, so in the process of electrolysis, we perform decomposition of solute. It could be acid, it could be base, or it could be anything. We can, in the process of electrolysis, we perform decomposition of solute in a solution, and through this solution we are going to pass current. Okay, so decomposition of solute takes places in a solution when current is passed through it. For demonstrating this whole process, we will carry out one activity. In this activity, we will take 1 gram of copper sulfate in 50 ml of water. We are taking 1 gram of copper sulfate, that is CuSO4, in 50 ml of water. 1 gram of CuSO4 in 50 ml of water, and we are using thick plate of copper as anode. We have used here thick plate of copper as an anode. We will call this plate as anode because it is connected with positive terminal of battery. Okay, we are going to use thick plate of copper as anode and carbon rod as a cathode. Copper plate is connected with positive terminal, so it is called as anode, and carbon rod is connected with negative terminal, so it will be called as cathode. Okay, now we are going to pass electric current through it. We have used here 6-volt battery, and with the help of this battery we are going to pass electric current through this solution. Okay, when we pass electric current through this solution in this beaker, the copper will get deposited on the carbon rod. As the current passes through this solution, how the current will pass? As we all know, electrons always flow from negative terminal to positive terminal. So the current will flow from positive to negative like this. Okay. So as we pass current through this solution, the copper will get deposited on the carbon rods. I will explain the process. As we connect the battery by turning on this switch, the electrons from negative terminal will move like this. These electrons will enter into this carbon rod. As these electrons enter into this carbon rod, there are Cu++ ions which are already present in the aqueous solution. These free electrons will combine with Cu++ ion, and they will form normal copper atoms. I am again repeating the point. The electrons coming out from this carbon rod, these electrons are coming from negative terminal of battery. They combine with Cu++ ions, and they will form copper atoms. These copper atoms will get deposited on this carbon rod. The remaining electron will now move towards this copper rod, and they will flow through this copper rod like this, and finally they will reach to the positive terminal of battery. Electrons are moving from negative to positive, but current will flow from positive to negative. Okay, don't get confused. Electrons moves from negative like this, from here to here, and then finally reaches here at the positive terminal. But the conventional current flows from positive to like this, negative. Okay. As the Cu++ ion got attracted towards the carbon rod, we have explained this earlier. These Cu++ ions will get attracted towards carbon rod as it is connected to negative terminal. And again the Cu atoms, that is normal copper atom, will be formed when the electrons coming out from the carbon rod, they combine with Cu++ ions. The electrons coming out from the carbon rod will combine with Cu++ ion, and as we all know, Cu++ ions, one Cu++ ion has a deficiency of 2 electrons. So If any two electrons coming out from this carbon rod combines with one Cu++ ion, then that Cu++ ion will get converted into normal copper atom. Finally, as the electrons Cu++ ions are getting converted into normal copper atoms, the deposit of copper will appear on the cathode, that is carbon rod. In this way, the deposit of copper will be seen on this carbon rod. Okay, so in this way electrolysis is carried out. In the process of electrolysis, we have taken copper sulfate, and from that copper sulfate we have separated copper. Okay, so in this way we have carried out the decomposition of solute, that is copper sulfate. So this was all about electrolysis. In electrolysis, we have performed decomposition of solute, that is copper sulfate, CuSO4, in a solution when current is passed through